28, determine if it's one-to-one. So first of all, it's got to be a function. So function, okay, is it one-to-one? Do the vertical first to see if it's a function. If it is, then do the horizontal, and this guy is one-to-one. So this guy's a yes. This guy's not a function, so he cannot be one-to-one. This guy is vertical, yes. I'm sorry, horizontal. Let me rephrase. Vertical, yes. Horizontal, yes. This guy is also one-to-one. Okay, so that's all you got to do. Make sure one-to-one. Now those one-to-one functions are great because they have inverses, and they won't cause any problems when you're trying to do switch your axes. Okay, but anyways. We're going to find the inverse, and then we're going to graph the inverse. Now, graphing the inverse should have a special character and value to it, so we're going to go ahead and check that out. So let's go ahead and actually graph this one. If we were to graph square root of x plus 6. Okay, so that is, I need to change this guy so that it looks like parentheses, because I've got that 6 there. I'm actually going to have that. Now, you can use your graphing calculator to see what this guy looks like, no problem. Okay, it's not that big of a deal. But let's look at this right here. This guy is going to be a reflection on the y-axis, and he moved 6 to the right. So 1, 2, 3, 4, 5, 6. But instead of going this way, he's going to go this way. So we move over 1, he goes up 1. 4, it's 2. Now this is just the parent function now. There's nothing else going on. The negative sign is just forcing you to go this way. But notice though that there are no parentheses. So you've got to put parentheses in, okay? And if I do that, I've changed the value, okay? Because now the negative sign has to distribute. So remember, if you're going to do any kind of horizontal compressions, stretches, or reflections on the y-axis, you do need parentheses there if there's something else attached to the x. Okay. So the next one would be 9, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it would be 3. So that is good enough for me. Okay, that is the original f of x. So now let's get the inverse. Okay, so the inverse requires me to swap out this, and at this point I don't have to do I'm not graphing this right here. I need to solve for y. So the first thing I need to do is to go ahead and square both sides so that negative y plus 6 is out. And then I'm going to move the 6 over to the other side. But I still equal negative y, so now I'm going to then make it negative. So I'm going to divide everything by negative. Okay, so that would give us negative x squared plus 6 equals y. Okay. Now, negative x squared plus 6. So what this guy would look like is he's a quadratic, and he's going to go up 6, and he's going to go point downwards. Okay. But the thing is that when I actually when I do this, okay, the inverse, okay, I can only have one of the arms here. I can't have the other arm because he's a quadratic, okay? I need to have the part that is going to reflect on this guy right here. I can only have this piece that is greater than 0. This other piece, it will not reflect to this guy because we only have one piece of the quadratic in order to be a function, okay? So we need the part that is greater than or equal to 0, okay? So that would be up 6, 1, 2, 3, 4, 5, 6, and he's going to point downwards. So that would be 1, 1, and then 2, 4, and then 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Okay, and then we want to tilt this to make sure that we do have symmetry along the diagonal. Okay, and that's what we have. So that is our answer. So what you might have to do is, if you graph this guy, okay, and this is confusing, graph the whole thing, but do it lightly, okay, and then basically erase the part that does not have a reflection, and then you can see, oh, okay, I only want the part that is greater than 0, okay? Okay, so next, here we have a rational function here, so this ought to look pretty cool. We're going to go, we know that it looks like this, but because of the negative sign, he will look like this, okay? And we're going to move over to the left 4, and then we've got that 3 going, so we want the multiples that equal 3. So we're going to go 1, 2, 3, 4 to the left, okay? And then we're going to make our asymptotes, okay? So I'm actually going to use 2 different colors here. I'm going to use pink, and then I'm going to use blue, okay? All right, so I'm going to graph this guy. I'll do my algebra, get the other guy, and we'll see what we got. All right, so now I'm going to then, because I didn't go up at all, okay, I'm going to graph him just as he is. So he's going to now have to have multiples of 3. But remember, I'm doing these guys. So my curves are in these 2 quadrants, not these 2. So if I'm over 1, I can go up 3. 1, 2, 3. And if I'm over 3, I can go up 1. That's actually going to be good enough. So this is all I need right there. Okay. And then over here, I've got 1, 3, and then 3, 1. So this is good here. Okay. Okay. All right. So now I need the reflection of this guy along here. So let's see what that looks like. So we're going to have to do some algebra now. We can put x here, and we go, I'm going to move that negative sign up to the 3, and we'll just do that. Okay, so now this is great, because what I can do is, a beautiful algebra move is, if I divide both sides by x, and if I multiply both sides by y plus 4 at the same time, what I can do is I can completely swap. I can just change those. That's a perfectly legitimate move here, okay? So what this then means is that all I got to do is now add 4. Okay, so the inverse of f of x equals negative 3 over x plus 4. Now what this is great is that this means that it doesn't move over to the left or right, it just goes up 4. Now I would have never really kind of thought that, but this is great. So what this means that, wait a minute, negative, oh, I'm sorry, it should be a negative there. Because going up, I just realized there's no symmetry, so you'd have to go down. So yeah, so now this is good. This is good, because when we move this guy over, he should have been negative. Okay, so now I'm going to do it in blue. Now what I have to do is completely ignore what I see in pink. And so I'm going to not move over to the right or left, okay, but I am going to move down 4. So, okay. All right, so not moving up or down. I don't want to do black. Let's see blue. This one. There we go. Okay, that's on 0, 0, and then down 4. So 1, 2, 3, 4. Okay. So now he is also got a negative 3. So what I'm going to do is I'm just going to go, now I got to completely ignore the pink here. So 1, 2, 3. Okay. And then I've got 3, 3, 1. So it looks like they actually share this right here. But he is going to do this. Okay, cool. What we just did is we reflected this curve right here, this pink one, we reflected with the blue. Okay, cool. Now when we do this quadrant, we're going to reflect that guy. So this is pretty cool. When I move over 1, I go down 3, and then I go over down 1, I'll go over 3. So that would be right here. Okay. Okay, and then I will turn it, and there she is. Okay, that looks good. Okay, pretty tough to do without the algebra.